I came back to do number 3, 4, and 5. 3, 4, and maybe I'll just do 3 and 4 in this video. 5 looks a little bit longer. Okay, number 3. Upload sample 3 into StatCrunch, then answer questions 3 to 5. Okay, so go to StatCrunch, upload data, load from file on my computer. You guys have done this so many times, so you're okay with me going just right? You're okay. And then I'll go drag. What's the word? Drag, right? Drag the sample over here, and I'll click on upload. What are we doing with this? 100 males and 100 female students. It says, conduct a test of null hypothesis that the proportion of males who are left-handed is equal to that for females versus the general alternative of some differences. How many left-handed people do you guys know? I know one person, for sure, my brother. I am not left-handed. So is there a difference? Are males or females more likely to be left-handed? I don't know. That's an interesting question. So let's see. Select stat proportion, because we are looking for the proportion of people with left-handedness, right? Select stat, proportion stat to sample, click on with data, and we're going to have to use the build function again, right? Sample 1 is handed, where gender equals female. Okay, so sample 1 is females. And we're only looking at the handedness, okay? And sample 2 is handed, where gender equals male. Choose hypothesis test and fill in the appropriate values for the null, difference, and means, and the direction of test. Direction of test is the not equal to symbol. And success is L. What does that mean? Success L. L stands for left-handedness. So we only care about the proportion of people who are left-handed. Okay, that was wordy, but let's see what we can do together. So go to your sample, click on stat, proportion stat, to sample, and go with data. Okay, this is where you want to go. Click, and for sample 1, click on handed. Success is L, and let's build that we want the gender to be equal to female. Was female 1 and male 2? I think so. Let me just double check. Sample 1 is female. Yeah, so we're good there. Okay, let me show you what I got so far. Okay. Click OK. And for sample 2, I'm going to click on handed. Success is again L. Build is to be where gender is equal to, no, not language spoken. Oh goodness, let me try again. Oh, build handed equals, oh no, dear, I'm so sorry, I'm distracted this morning. Gender equals male. Okay, I'll go ahead and zoom in here so that you guys can stop the video and take a look. Sample 1, handed, success is L, where gender is equal to F. Sample 2 is handed, success is L, left-handed again, but this time gender is equal to M. That's what you want. And what we want is to test that there is no difference for the null. So when you do P1 minus P2, they're truly the same, then it's going to be 0, right? Versus P1 minus P2 is not equal to 0. That's perfect. I'm going to go ahead and hit on compute, and we will get this. Okay, I'm going to go ahead and take a picture of this. I do want to have how many at least? 5 of each. I'm hoping. Let me see. I'm lucky because there's 7 left-handed females, and there are 7 left-handed males. What? So guess what, you guys? I have the same exact number. So of course, my conclusion will say there is no difference. Okay, the proportion of people with left-handedness, if I'm just looking at females versus and the proportion of left-handed males in this data set, I'm gonna say that they are equal, right? They're exactly the equal number. But and also look at that p-value. P-value is 1. That's as big as it gets. That's the biggest p-value. So I definitely, completely, totally failed to reject the null. Okay, I failed to reject the null, and I shouldn't say I have evidence to believe, but there's no evidence to believe otherwise, right? Okay, there's no evidence to believe that there is a difference. So let's go ahead and type up the that was cool that I have 7 and 7. Give me 1 second. I'm gonna zoom out a little bit, and I'm gonna try to put them in the same page. Interpretation now. Is there statistically significant evidence for the difference in proportion of left-handedness? No. In my sample, no. Maybe in your sample, but mine, the p-value came out to be 1, and that is the biggest p-value. It says your explanation should be phrased similar to question 1. So you can copy that, or I may just write it myself. Okay, I'm gonna go ahead and try to write it myself. Is there statistically significant evidence? No. Because my p-value equals 1, which is greater than 0.05, I have no, oh no, I'll go ahead and say I fail to reject the null hypothesis. I have no evidence. I guess I can say I have not enough evidence to reject the null, or reject to believe that the proportion of left-handedness in females is female students. Okay, female students is different from the proportion of left-handed students in male left-handed. I'm horrible at this. I'm sorry. In male students. So that's my sentence. I think I mentioned everything. I mentioned that my p-value is 1, which is greater than 0.05. And then I said I failed to reject the null hypothesis. I failed to reject it. I don't accept it, but I did fail to reject it. So my conclusion was inconclusive, right? I do not have enough evidence to believe the alternative. Okay, I do not have the evidence to believe that they're different. I do not have evidence to believe that the proportion of left-handedness in female students is different from the proportion of left-handedness in male student population. I guess I can add, there is no statistically significant. Oh, I may add that part right here. There is not enough evidence. There's not enough statistically significant. My sentence is probably not that good, but it covers everything. It talks about the p-value, how we are comparing it to the alpha level. Based on that p-value, what did we do? And I try to add another sentence about our conclusion, okay? Or you can just simply copy this part and just change the wording, okay? But I did go over number 3 and 4, and I will come back and do how about we just do it right now? I think we can do it right now. So construct a 95% confidence interval for the difference in the proportion. What I know is mine is going to definitely include 0 in it because there was no difference, okay? 95% confidence interval. And this is going to be easy because we already have everything typed up. Just click on options, click on edit instead of starting over again, and then I'll go ahead and just change it to confidence interval for P1 minus P2. Level is 0.95 and compute it. And that's all. And we'll talk about these very significant numbers. First of all, so the difference the difference is in between negative 0.07 to positive 0.07, right? Because guess why? My point estimate was at 0. So with a margin of error of 0.07 to the right and to the right and to the left, I have this confidence interval. So notice that the left bound is negative, or the upper bound is positive. It definitely includes a 0. And when the confidence interval includes a 0, that tells us that there is no statistically significant difference between these two parameters that we were comparing, or estimating to compare. So is there statistically significant evidence for a difference in the proportion of left-handedness? The answer is no. I'm going to go and copy this sentence. Now I'll go ahead and just change it up. Okay. I'll go ahead and change this up. Whoopsie. And I don't know who is watching this, but I'm just creating extra resource in case you guys want to do this with me. So if I'm messing up, or if you hear noises in the background, hopefully you are okay. There is not statistically significant evidence for a difference in the, we have to change this, right? In the proportion of left-handedness. And I can be a little wordy, but I guess this is okay. Since the null difference of 0, right, is in the 95% confidence interval. And that's it. And I wish one of mine, because I think some of you will get a completely positive or completely negative confidence interval. I didn't. Okay. I hope I got a case like that. And if you want me to look at your data set, like if you are getting different, because it's all random samples. So if yours is different, if you want me to look at yours, I can do that. Just email me, okay? So that's it for number 4. I will stop this video and I will come back and do number 5 a little bit later, okay?